One of the next projects on this Blazer, well, we're redoing the air intake, and we're not using aluminum. We're actually going to 3D print an air intake and see how it holds up. I've got some new material to try out, and while this works and it does an adequate job, let's be real, guys. It's cramped, it's tight, and these bends, I've got to tighten them up because I'd like to pull this end about right here to where I can send it through the gap over here with a tensioner and stuff, and I can turn this mass airflow sensor a little more straight up, but it's all tight in here and there ain't much room. So what we're going to do is we're going to design an adapter that bolts up in place right here. We might be able to remove this back plate and just create new adapters that bolt up in place of these aluminum pieces that are directly to the tube. This one here, we're going to put an aluminum insert inside the 3D print, and we're actually going to take our 3D prints, we're going to wrap them in carbon fiber and soak them in resin. That's right, we're going to use 3D printing to create an air intake tube and then make it carbon fiber. I like that idea. I've not done any fiberglass work of that nature. The other fiberglass project is we're going to build a new heater box side because the lack of room is highly disturbing. Forget changing number 8 from the top. You got to do it from the fender well. But we're going to redo our air intake. I mean, I wouldn't mind sending it out the driver's side because it would clean up some stuff. But we're not going to be picky about it, if you catch my drift. So follow along, and we're going to head to the computer and see what we can get done there. Alright, so we're at the computer, and I've got some basic shapes drawn up and guesstimated here. We're not going to hit print on anything yet, but let's get to how we got to our measurements. And first things first, we're going to grab our old trusty Harbor Freight digital dial calipers, make sure they're zeroed, and we're going to take and measure across the diameter of this tube. Now I'm going to take and try and get just the outside here, and 76.6. That's cool. So now that we have that measurement, we're going to go in here in our bent pipe in the shape generator on Tinkercad. You can do this too at home. You don't have to have the world's fanciest computer to do so. And let's be real, this is free. You just need to log in. If you got a Google account, you can just sign in with it. Have fun. And you'll click more shapes, scroll down. Actually, you don't need more shapes. The one you're looking for is right here. It's on the bent pipe. Now, and for our throttle body angle, we just use 90 degrees and we run it out. All the measurement, you can choose to do your measurements in either imperial or metric. I just use metric because it's easy to work in groups of 10. And I know that 25 millimeters, it's actually 25.4, equals an inch. So I know if I use 102 millimeters that I've put 4 inches on the end of whatever I needed to. And over here in your bent pipe configurator, that's what we're going to call this, is you got your choice of pipe shape, circle, or in hole. Your outer pipe width, this is going to be the measurement we took just a moment ago. Notice that we're using 75 and not 76.6. We're doing this because we need to leave a little room for carbon fiber material thickness. Wall thickness, 1.2, that is 3 passes. If you're just using this as a template, you can leave it set at that, and then when you print it in vase mode, and it'll only print the outside edge. Something to keep in mind. Arc diameter. Now this is where you have fun. You can tighten up the radius of your curve or expand it out absolutely absurd. Part of what we're doing here is I've got a lack of space, so we're using tighter radiuses than we would normally want to use in a situation like this. Only because I ain't got no space. You know, this thing's tighter than none. Yeah. We're gonna leave that joke right where it was at. And like I say, I wanted everything to bolt up, so I've just left a space here as a placeholder for the mass airflow sensor for the time being until I can draw one up. And you know, on my mass airflow sensor, I want everything bolted. I want to bolt everything up. And on the back side here, I think I'm going to include this vane on the 3D print itself and replace this back housing with a 3D, to make it where the tube just bolts up in the place of this back housing. And up front, that mesh comes out, so I might actually measure to pull the mesh out of this one. There's just snap ring in here. And we'll put this mesh inside the air intake tube like it would be from the factory. And we'll just have our air intake tube bolt up to the mass airflow center section here using this mesh section and a mesh section and a 3D copy of the back half. I think we'll have something there. Worst case scenario, we take on the front half, we leave everything here, have our air intake tube slide up and over, and we pull these bolts out and we replace them with longer ones, put our other section of the air intake tube in, put our bolts in, nuts, washers on the back side, everything's secure, tight. There's that none again. And, we'll see how it works and goes from there. Good news is it'll all be securely mounted, and it's not going to be, this isn't going to be as easy to work on as it currently is, and I'm okay with it. Sometimes ease of maintenance, which I do think about when I'm building this stuff, how easy is it going to be to maintain? Sometimes it's not always peaches and cream or roses, however you want to look at it. Occasionally, when you want something nice, you're going to take a little bit of the ease of maintenance away from it. It sucks. It's going to happen. But you can at least try and think about how you're going to have to maintain it. So, like when I put the mass airflow section in here, we're going to make sure that the bolts and nuts that are there are normal, non-Allen head bolts, where if something happens and I have to put a mass airflow sensor in it on the side of the road or in a store parking lot, I don't have to have specialty tools to do it. Yeah, you're going to dismantle a perfectly good brand new mass airflow sensor. Guess what? I'm okay with it. And actually, what I may do is when I get ready to do the carbon fiber polished up, take this bad boy right here, take it apart, polish up this flange right here, like right here, clean all this up, put the resin on there and put the carbon fiber tube on it, and then basically incorporate this aluminum flange into the carbon fiber tube, and could probably do the same on this one. And then you just change the center section of the mass airflow sensor if something goes wrong. I like that idea, actually. We just incorporate what's here, and I happen to have 2 or 3 of these that are dead, and the good one that's on my Blazer, so polishing one of these up, making it look nice, I'm down with that idea. I really am. Okay, now that y'all have got like a whole fuck ton of rambling and a little bit of design process and theory here, bend angle, your lead in and lead out length is how much straight pipe is before and after your bend. And honestly, let's scroll out of here, push that back out of the way, and let's go in here and let's create a new section. Outer pipe width 75, wall thickness 1.2, arc diameter. You know what? Let's make this a 4-inch mandrel. So knowing that, it's going to be 102 millimeters, makes 4 inches. So when we look at this, that right there is a nice, smooth, arcing turn. But when you're in a tight space and you really don't have that, so let's try this at 51. And you're going to see how much tighter that pulls in. That went from, you know what, let's just do it this way. Copy, paste. And then we set this one up at 102. And we change the color of it to yellow. And then we've got this purple one here that is half at 51 millimeters. Oops. Delete that one since we don't really need it. Now we'll hit this one. And there you go. So we managed to pull it in 2 inches this direction, and it pulled it back an inch. That's cool. So what I would do is I would take and I would draw up 2 or 3 of these. You can do short legs on them so you're not spending a ton of material, but put some kind of leg on them so you have an idea of where you can go. And I don't have anything printed. I just happen to have some aluminum ones, and I've duplicated and kind of figured out what the bend radius was on them. And knew that I wanted shorter for what you've seen in the opening there. I needed something, I wanted to pull everything up, lay it out nicer, neater, improve how it looks and functions overall. Because honestly, right now, we're one step away from hammered dick. We don't like that. We don't. I know this thing was put together in a hurry. Even though I could have done a better job at it while I was in a hurry, I didn't. Whose fault is that? Mine. So now, go in here, print you out 1 or 2 of these and various things, put you a couple of different bends, print you one out with a 45, one with a 30, one with a 75. That way you can hold stuff up in your engine bay, mock it up how you want it, and then you can further design it. Now, I'm going to end this video here before we go into the 3D printing process. We're just going to do design basics today and why we want to do what we do. Like I say, I want the mass airflow sensor to bolt in with no rubber couplings, no clamps. Does make it a little harder to work on, but like I said, we may even use the stock bolts and just make sure that the tool we need is in our toolbox to work on it. Because our travel toolbox is going to be fairly light and simple. Because there's not a ton of stuff that is, most of this thing's 8, 10s, 12s, 13s, 15s, and an occasional 19 and 21. There you go. Build an S10 in a kit. So, like I say, we'll take this purple one here, and I want to make it a 45. So we go over here to the bend angle, we highlight it, we change it to 45, and let's hit the lead out length, and you know what, let's just make it 102, or 100 even, just because that's what we done. And we'll give it a second, it'll populate up, we'll move this 90 out of the way. So now I have a 45, and we'll do a 50 millimeter lead in. So there you go. Now I've got a pipe section that is pretty easily duplicated in aluminum. While that one right there is about what you'll get in most aluminum intercooler kits. Sometimes you just need something thinner. So there's those. And then there's where I'm at with this one. So when I print this, I'm actually going to try and print this section as 1. And then over here, I'm going to print these 2 pieces as singles, I believe. Because that one right there, it's got less angle, so I don't have to use as much support structure. And then this one right here, I'm going to have to use supports to hide some areas when I print it. We're not sponsored by any 3D printing companies, but if there's a 3D printing company out there that'd like to see their project on my workbench or see their printers on my workbench, reach out. Contacts in the contact below. So we're going to refine on this for a little bit, and all these designs, after they're finished, tested, and printed, and installed under the hood for mock-up, will be available for purchase for your own LS Swap S10. I'm not just doing this for mine. I'm doing this for more than... I've got another one sitting here. Y'all ain't seen no videos on it yet. But I promise you they're coming. You know, things are just... work's getting in the way, but but doing what you got to do, you'll make do with everything you need to do. Yeah, that's what we're going to do. We're going to stick with that. So we're going to continue to work on this, and we'll have the next time you see us on this project, we'll be test fitting all of our 3D printed intake tubes. I'll even have some of the 3D print processing while we're at it. And we'll see what happens from there. So there's where we're at in the air intake project on the Blazer. We're still in the design phase, but y'all pretty much seen, outside of a handful of bins that I've drawn up over here on the computer, y'all seen about everything. I've even showed y'all how I done those bins. So there's an introduction to TubeWork 101 and Tinkercad, how to get there, how to use it to build you, that's right, you, an air intake for your hot rod swap project. And it doesn't just have to be an LS. We've got a Dodge Ram coming up. We got to do transmission, we got to do torque converter and flex plate, figure out why the throttle body doesn't work. We're probably going to have to get into the fuel system. This thing's been sitting for 10-ish years in my backyard. And we're going to have a Will It Run series on that Dodge Ram coming up. I'm not going to say in the next 60 days, but we're going to try and time it around then. We know we've figured out what parts we need. We're going to buy a fuel pump, keep it on, or we're going to figure out a fuel pump. We're going to figure out a few other odds and ends. But next up is getting this air intake. We're going to finish up the design, a couple of flanges, either draw up some flanges or take a few more measurements so we can kind of butt some stuff up. And we're going to make sure that we keep it tighter than that nun we talked about. You know, got to do what you got to do. And we're going to have a lot of fun coming up, guys. I promise. Just hang in there with me. I know that a lot of people that was here for all the old shorts, comedic genius that I had, there's still going to be some of that here. But for long form content, y'all going to get hot rod stuff. There's going to be hot rod stuff in the short form too. Look, guys, y'all going to leave, y'all going to leave. I can't help it. But for those that want to see hot rod content, occasionally learn how to mess with some HP Tuner stuff, or Mega Squirt, because let's reach over here and grab this unit. It exists. And as far as I'm aware, we're going to find out. We got to put some software on a computer here. It still works. So stay tuned for that, because that'll be an interesting experience. And what else do we got? What else do we got coming up? We've got our S10 project for a gentleman. He is we've made progress on it. There's video to come on it with all the suspension work. I can't wait to actually start sharing videos on this project. We are going to have the motor out of it. We're going to go through and do a few things on a we're going to do a motor build review. We're not going to tear this gentleman down in any shape, form, or fashion. He's asked me to go through it and do these things. So we're going to go through and we're going to check ring gap on it. We're going to port the oil pump. And then while we're in there, we're going to go ahead and inspect bearing clearances and and we might even see about degree in the camshaft. But for the Blazer, our current projects on it, air intake, we're going to get that done. That's one of the next projects. I'm at least going to get it printed or 3D printed and mocked up. The carbon fiber stuff or fiberglass, I'm going to have to kind of wait and see what happens on it. We also have some more fiberglass work coming up on how to narrow or how to modify your AC box for this second gen LSS10 swap. Hey man, it's got to be done. As you've seen earlier in the video, there ain't no room. Absolutely, you can't change the number 8 spark plug from the top. I've tried. The last time I done it from the top, I just unbolted the header and slid it forward. Didn't have exhaust on it at the time, so it made sense. Now there's exhaust on it. And, you know, V-bands make things easy, but boy are they a pain in the ass in its current location. We did get our wideband O2 installed in the driver's side, but we think we missed it or it's got an air leak because it's reading a little leaner than it's supposed to. So we're not going to use it for tuning as of right now. We'll follow more into that in the future. So the S10 project is up next. Coming up soon, we're going to have a second gen Camaro coming in, getting rear brakes, motor pulled out. We're doing a set of Rhodes lifters, rear main seal, intake swap, and the gentleman's asking me to go through the carburetor. We're gonna see potentially that we can get a quick fuel carburetor put on this thing and adjust a little bit of fuel pressure. This car, at least drivetrain wise, is done. It's done right. It's got a turbo 400. It's got 411s in it. We may put some 342s in it just to kind of make it a little more street friendly. Hence the reason why we're doing the Rhodes lifters. He's got a big cam in it. Doesn't want to lose top end, but wants a little more bottom end. Way to do that, make the cam think it's smaller than what it really is. Rhodes lifters allows us to get that done. Guys, I've got a ton of projects sitting here and working on them. Sometimes it's a budget deal. I just ain't got the money to do what we need to do here. But I do what I can with what I got to do with. So, also coming up on the Blazer, we've got front suspension. We've also doing front suspension on the S10. So I don't think I'm going to do 2 videos on it when I'm doing it on the S10 project. I'm just going to knock it out on the Blazer. We're doing new control arms, uppers, lowers. We're going to put fresh bushings and ball joints in it. I kind of want to do the 1/2 inch taller lower ball joints. You know, that's after taking it on the cruise I took it on yesterday, it could use it. It carves a good corner, but it could be better. It could be just a little bit better. A little bit. Yeah. So stay tuned. We've got a lot of stuff coming up. I'm kind of slow about it. I've got a fiberglass hood install video. I'm going through and pulling there was some discussion parts in there between me and the guy that was doing it on what needed done so we could, I mean, it was basically, we would look at it, talk about it for a moment, and I've got to go through and pull those sections out because I time-lapsed them all and kind of missed it. So we're having to re-edit this video before we can upload it. But we do have a fiberglass hood install video coming up on a Mustang. It's a race weight hood, super light, super thin. It was an absolute, it wasn't a pain in the ass. It's just not the most fun in the world. I don't know that I would want to do it. I wouldn't mind. I would do another one, but I don't want anything race weight unless I'm pure track only. Nothing like that on the street. It ain't gonna last. Our other options are on the Ram. I'm tempted to cam it. Tempted. It's kind of expensive. It's about $1,000. But let's be real. It's about $1,000 to cam an LS2 by the time it's all said and done. Fight me. Prove me wrong. I've done it. So on the Blazer, we do, in our parts pile, we have a sloppy stage 2, a couple of turbos, and a 4L80. Anybody know where I'm going with this? The White Trash Yukon. That's it. The White Trash Yukon project is going to be an absolute riot. It's got a 300,000 mile 5.3 in it. It's got a 300,000 mile 4L shitty in it. We're going to pull the 4L shitty before it has a chance to die. It's going to become a backup transmission for the Blazer. Because the Blazer doesn't need a 4L80 when it doesn't even make 300 wheel horsepower. Prove me wrong. I can't justify the drivetrain losses for something that is daily driven. We'll put a 4L60 in it, keep torque management on it, and hopefully it'll live a long, happy life. We'll see. But the White Trash Yukon, we're at least going to strap a turbo to it and a 4L80. We got a sloppy stage 2 to shove off in that bad boy. We will pull the motor. We're going to pull the body off of it, pull the motor, go through the motor. I'll probably do rings and bearings. We'll gap them. And this is going to be my fun toy vehicle. I want the interior of it to be nice, so it'll have both heater cores front and rear. Air's going to work. We're going to clean the carpets, clean the interior up. I'm going to recover the front seats, make them nice. And other than that, we're not going to do much to the interior.
Pairing.
Oh, cool. Thanks, Bluetooth speakers. And then we're going to lower it 4 inches all the way around, maybe 5, depending on how it goes. And then under drivetrains where that thing's going to get it. I'm probably going to leave it on about some kind of nice looking stock 18 and call it good. I don't want to. I'm not after spending a ton of money. We're going to doll it up, make it nice as we can for what we got. It's a 300,000 mile beater that somebody else has owned. It's been hit about on every door panel, on every panel. So we'll just make it as nice as we can and enjoy it. Our next project, I want to build a limo, or I want to build a drag and drive car. We got to get the Dodge going first, because, you know, that'll give us something to go pull stuff home with. I can just go borrow a trailer. The Yukon, it'll also go pull something home. Just got to go borrow our trailer. So I'm about to have a tow pig. The Blazer, we're going to lose it because the kid's going to get it in a couple of years. He's coming up on that age. So, and he knows what's coming up next summer. He's got to pull the interior out of it. And when we do, we're going to go ahead and put sound deadener in places. I took it on a 150-mile cruise, exhaust closed, radio at a reasonable volume, and never had the first issue or out of place exhaust note. It was amazing. Our drive home was across a mountain, first kind of real mountain cruise that we've had on it. Got some issues in the tune to resolve as far as detonation and stuff that knock sensors didn't pick up, so I think we may have some bad knock sensors that we put in. And if that's the case, we're just going to turn them out, and it sucks. We're just going to deal with it. So, y'all have heard me ramble on long enough in this video. It's been an absolute pleasure. Till next time, this is the Captain, and we'll see you then.